Today we're going to talk about scientific math, specifically significant figures. In chemistry, we gather a lot of data, and that data can either be quantitative, which means that it involves numbers. So think about the N there, quantity or N as in number. Qualitative data is just more descriptive data. So if we talked about we had a sample of a silver metal that had a mass of 50 grams. The silver would be qualitative, and the quantitative data would be the 50 grams. But we also need to be accurate and precise when we are gathering data. So accuracy is how close it is to the actual value, and precision is the ability to get the same results over and over again. All right, so if you look at this dartboard right here, we have got the first picture here, which has the darts kind of all around the place. They're not accurate, nor are they precise. They're not near the bullseye, and they're not all together. If you look at the second one here, if you look at this one, you can see that it is accurate but not precise. So it's relatively close to the bullseye, but it is not, they're not in the same spot. Okay? Now if we look at this one right here, notice that they are precise. You are getting the arrow in the same spot over and over again, but you're not at your desired target. And then if you look at the very last one, it is both accurate and precise. That's what we're going to try to be when we are doing things in the lab. We're going to try to be accurate and precise. Okay? So, how we show our precision is with significant figures. The more significant figures we have, the more precise the measurement is. So if we look at this graduated cylinder here, and a graduated cylinder, it is a cylinder, and these lines are called graduations. And these lines can be closer together, and that makes them more precise. Now, if we were just kind of looking at this and glancing at this, we'd be like, oh, that's 45 milliliters. But we can be more precise with this particular graduated cylinder. And so when you're reading something like this, so you can obviously tell here that it goes up to 44 milliliters right here, right? We can tell that. But we can also see that it goes up pretty far past that. It's really close to 45. So basically we can read 44. So that's a known. That's known. But we can also estimate one digit and still be considered precise. So 0.9 is the estimate. So we would record this as 44.9 milliliters. And don't forget to include your units. Almost all numbers that we write in this class are going to be numbers. Are going to be numbers, obviously, and they are going to have units that go with them. Okay, so let's look at, so basically this says that you're going to estimate one digit, and this is one of the things that we're going to kind of play around with when we're in the lab, because this is probably not something that you're used to doing, but you can estimate one digit. And that also goes with a ruler. So normally, let's say you're measuring, you'd want to do 5.2 centimeters. Well, you could probably estimate that to be 5.25 centimeters. So let's go ahead and look at this volume measurement here. So we've got another graduated cylinder, and this one is kind of magnified a little bit, so you can kind of see what's going on here. But let's look at what this volume is, and I want you to write this in your notes also. So let's look at this. So here's 60, here's 70. Now you have to kind of figure out what these lines mean, because on a smaller graduated cylinder, those lines might be 1/10 of a milliliter, or it might be 2 milliliters. It just depends on. So you have to look at the scale and see what is going on. On this particular measurement, we've got 60 to 70, so each line is a milliliter. So we've got 60, 61, 62, 63. So we can tell that it is 63, right? That is for sure, but we can also estimate the last digit. And I would say that it is 63.5, okay? Now it's going to be hard to get, and actually know, okay, say 63.3 or something like that. But you can do the best you can with that last digit there and estimate that. Okay, so let's look at rules for significant figures. Now, let's talk about what digits are. Digits are just numbers. When we're talking about significant figures, instead of saying numbers, we're going to say digits. And it says all non-zero digits are significant, and that is exactly what it means. 1 through 9, not zeros, those are non-zero digits. So if you notice on the first example, all of the numbers here are non-zero digits. So there are 4 significant figures, 1, 2, 3, 4. On the next value, 1, 2, 3, 4, 5, we've got 5 significant figures. So that is very straightforward, and it should be very easy to kind of figure that out. Now, when we get to zeros, sometimes zeros are significant and sometimes they aren't. So zeros between non-zero digits are significant. Think about this as being like sandwich zeros. So notice, this 0 is in between 2 non-zero digits, so it is significant. So we're going to do 1, 2, 3, 4, 5, 6. So all of the digits that are in this number are significant, but I want you to look at this one. Notice this first 0 right here. It is not a sandwich 0. It is not significant. But these two are sandwiched, so they're significant. So you're going to count 1, 2, 3, 4, 5, 6. 6 significant figures. Okay? Now, the next rule, zeros to the right of non-zero digits are not significant. Unless there is a decimal point. So if we look at this one, you see how there are 3 zeros at the end of a number? There is no decimal point at the end, so there are only 3 significant figures in this value. 50 has 1 significant figure, but I want you to look at this last one. Notice how you put a decimal there? Now, if you're writing down 1,230, you're not going to automatically put a decimal point there, right? Unless you want it to be there. So the intentional placement of a decimal, that means that that 0 is significant and that number has 4. Okay? Now, leading zeros are not significant. Leading zeros are zeros that are in front of the number. They're just placeholders. They're just showing you that that is a small number. So notice on this one, none of those zeros are significant. It just has 3. In this one, you've kind of got a mix. You've got leading zeros and you have sandwich zeros. The sandwich zeros are significant, so this one has 5. Okay? So, if a number has a decimal point, the zeros at the end of the number are significant. This is the one that kind of throws everybody off. So in this particular number, we kind of have a little bit of everything. We have your non-zero digits right here. I'm going to put an arrow next to all the ones that are significant. Now, you also have a sandwich 0. Those are significant. These 2 at the end are significant because you have the decimal point right here. Okay, this is the hardest rule for students to get, and we're going to work on this, but the leading zeros in front of the number are never significant. So this one has 1, 2, 3, 4, 5, 6. 6 significant figures. Okay? All right. I want you guys to try. So if you look at these real quick, now I think there is a place for you to write this down in your notes. And I'm not looking for you to get all these correct necessarily. I just want you to try these. So if you need to stop the video and try these, I would like for you to practice and see if you can get these correct. All right, here we go. So if we look at the first one, we do have a decimal point. Now we have four non-zero digits, so those are obviously significant. These two zeros are at the end of the number, but there's a decimal point. So we have 1, 2, 3, 4, 5, 6. All right. I'm going to kind of erase this because it's going to be hard for us to see what's going on here on this next one. All right, so if we look at this one, we have a leading 0. It is not significant, but the ones at the end are. So we've got 1, 2, 3, 4. This one has 4. This is a sandwich 0, not at the end. Now, if you notice the next one, C, we do not have any decimal points in this number. So the ones at the end are not going to be significant. So I'm just going to kind of mark through those. But all these others will count because this is a sandwich 0. So we're going to have 1, 2, 3, 4, 5, 6, 7. Okay? Now, leading zeros. Zeros in front of the number are never significant. So this one just has 2. And look, we have a decimal point on this one. So we have 1, 2, 3, 4, 5. Okay? All right. So that's how we figure out the significant figures. Now, why do we do significant figures? Well, how many times have you asked your teacher, where do I round to? And they might say to the nearest whole number, to the 10th, or to the 100th place. Well, where you round to has to do with your significant figures, okay? They've just probably never gotten to that with you before. Now, and this saying here that they have is kind of very confusing here. But basically, you can only record your answer to the lowest number of significant figures that was used in the calculation. Now, we're not going to do a whole lot with adding and subtracting, but basically what you do is you have to kind of line it up the old-fashioned way like this. So we've got these two numbers here that we are adding together. Notice that this 2 here on the end does not have anything in front of it, so we can't count that. So we can go ahead and kind of add it all up, and we get 9.52. But we cannot count that 2 because we don't really know what's up here. So we get 9.5. I am not going to give you a whole lot of addition and subtraction. We do not do a lot of addition and subtraction in the calculations that we do. Most of what we do is going to be multiplication and division. So that's what we're going to focus on. And it's a little bit easier to understand the multiplication and the division. All right, so basically what you're going to do is you are going to look at the number of significant figures that are used in the calculation. So notice this number right here. This first one has 3 and the second one has 2. So the lowest number of significant figures that is used in the calculation is 2. That's what we have to round our answer to. So notice that we rounded it to 44. Okay? All right, so we're going to go through and we are going to do these. And I just realized here that I don't have the answers. I'm going to pause for just a second and then I'll come back. All right, I'm back. All right, on the first one, I apologize, guys. So we've got 4 4.6678 minus 0.227. So you have to kind of line it up. So I'm going to put that in, 4.6678 minus 0.227, and you're going to get 4.4408. Notice that this 8 does not have anything underneath it. So you are going to have to just record this as 4.440. All right, let's look at the division. So 45.889 divided by 0.0450, and you get the answer that you get when you put it into your calculator is 1019.75556. Now you're going to want to round that, right? You're not going to keep all that. I'm going to erase this. Okay? So where do we round to? Well, I want to look at how many significant figures are in each of these values. Whoops, sorry. Okay, so if we look here, we've got 1, 2, 3, 4, 5, and then we've got this first 0 does not count, but the last 0 does, so we've got 3. So I'm going to round to 3 significant figures. Now on this one, sorry, I keep magnifying it. On this one, now normally we do not want to round once to the left side of the decimal, but sometimes we do. Notice this one is going to end up being 1020, and I'm not going to put a decimal point there because that last 0 is not significant, so that gives me 3 significant figures. Remember, if you have 4 or below, you stay down. 5 or above, you round up. Okay? Now let's look at the multiplication one. So we have 98800 times 12. So we're going to end up with 1185, and then we've got 600. All right, so notice this one has 3. There is no decimal point. This one has 2. We are going to round to 2 significant figures. Okay? So now, we don't usually think about rounding numbers that don't have decimals, but in this particular circumstance, we need to. We actually need to round right here because we only want 2 significant figures. So it's going to be 1, 2, 0, 0, 0, 0, 0. So you've got to make sure that you still keep those zeros. They're placeholders. They're not significant, but they have got to be there to show us the value of the number. Now, next class we will look at scientific notation, and it makes a little bit more sense if you put this into scientific notation. 1, 2, 3, 4, 5, 6. That value makes a little bit more sense. Okay? All right, let's go on to the next thing here. Oh, no, that is all that we have for today. So I'm going to give you some practice with this. I don't know if it will be this class block or if it will be the beginning of the next class block. Just depends on how much time we end up having. I think, at least for you virtual students, I think it will be the next class block before you get some practice with this. Do your best on this. I know that this might be a little strange, and this is usually something that we kind of work together. We get the whiteboards out and we do a lot of practice in class. So we're just going to have to find a new way to kind of practice with this. But try your best, and on the assignment that I'm going to give you, just try your best. I will give you feedback on how you did, but just try on this, because the thing with this is we are going to be using this all year. And not that I'm going to take off tons of points if you do it wrong, but I will count off a little bit on assessments if you do not round in the right place. Use the correct number of significant figures. Email me, call me if you have any questions. And I do apologize if y'all heard some sound in the background. There is some grass mowing going on that kind of messed up my sound here a little bit. So, all right, thanks.